Okay, so here we have the next question on the menu today, and it is presenting the situation where we have a triangle where we have one charge like this, charge A, which is 9.6 microcoulombs, 9.8 actually, which is equal to 9.8 times 10 to the negative 6 coulombs. And we have point B over here, and point B has a charge of negative 1.4 microcoulombs, aka 1.4 times 10 to the negative 6 coulombs. Okay, and we have point C that is kind of like, if this was a right angle triangle, C would be where the right angle is. C has no charge, and the distance between these two, let's call this RAC. Here we have 2.1 centimeters, also known as 0.021 meters. And this distance over here, well, similar arrangement, different distance, 9.6 centimeters, 0.096 meters. Okay, always great to do these conversions ASAP fast and do all your calculations in base SI. The question is asking us, find the electric potential at point C. So to do this, what we have to do is electric potential equation. It looks like this. So it's represented with the letter V. It's also commonly referred to as voltage, but we say electric potential for like more of these electrostatic type of questions, and we say voltage more for like electric circuits. But you'll see that plenty, I'm sure. To calculate this is just K Q over R. This distance, let's call this BC. BC like because. Okay, so essentially what we just got to do is the total electric potential at point C is just going to be the electric potential as a result of A at point C plus the electric potential as a result from B on C. To do this, well, it's just going to be K QA over RAC. Right, it's not squared on the bottom, right? Yeah, awesome. And plus K QB of RBC. Cool. So if we see that we can factor out the K term to make this calculation just slightly easier, less typing in the calculator, which is good because every time you type into your calculator, you have the risk of hitting a wrong button, and only one wrong button press is enough to crash the boat. So, if you set up your algebra so that you have as little typing into your calculator as possible, the better it is, and it'll also be faster. Not only about precision. Okay, so let's sub in our numbers and figure out what in the world this electric potential value is going to be. Okay, so our K value, that is 9 times 10 to the power of 9. Coulombs constant. It's a good thing to memorize, but you'll most likely have it on an equation sheet if you see this in a test. Okay, and then we have QA. That's a positive one. We got to keep these signs, front and center in our mind. Times 10 to the negative 6 coulombs. Over the distance between A and C, that is 0.021. I'm about to turn 21. Fun fact, it's almost my birthday. Cool. And then the second one is going to be QB, which is negative. Don't forget the negative. If you forget the negative, it's going to hurt. Okay, so let's incorporate that. Plus negative 1.4 times 10 to the negative 6 coulombs. And that distance is 0.096 meters. Cool, so let's send this to our calculator and figure out what this is going to be. 9 times 10 to the power 9 times 9.8. Oh, this all got to be in brackets. 10 to the negative 6 divide by 0.021 minus, don't forget the minus, 1.4 times 10 to the power negative 6 divided by 0.096, close the brackets, and I got an electric potential calculation that is pretty large, can't lie. Oops. It's equal to 4,068,750 volts. Yeah. So yeah, we got the precisely the same calculation here. So yeah, this is how you do it. The calculation is agreed here, and yeah, everything's good. So good job. That seems pretty high. Like that would be like your wall is only 120 volts. So that is quite the electric potential here, but that is like you know, like microcoulombs is a decent amount of charge, and centimeters away, that is very, very close. So it does seem and feel like a reasonable answer. So yeah, cool. So nice.